So hey guys, welcome to HS Academy. So guys, in today's video, we are going to learn about what is the meaning of a hazard. Okay, but our approach is going to be totally different. First of all, previously, what we used to learn, hazard is anything which is available in our workplace and have the potential to cause harm. That is the meaning of hazard. That's complete. Okay, and we will give some of the example. But in the real sense, when we go to the system safety, the meaning of a hazard is totally different. So we are going to discuss that meaning. Okay guys, so first of all guys, let me clear you, hazard, the definition what you have studied is not totally correct. Okay, as per the system safety, hazard is a event, is a potential event. Okay, hazard is a potential event, not a actualized event. It means what you have told in the previous definition, hazard is anything which have the potential to cause harm. It means hazard have the potential also and it is causing the harm also. Okay, but in the real time, hazard didn't cause any harm. Hazard is just a potential event, and whatever the harm you are seeing in the actualized event, that is called a mishap, not a hazard. Okay, so hazard is different, mishap is different. Hazard is a conceptual concept, as well as that particular mishap is a actualized event. Now we'll give you one good example. For example, just consider I have this kada. Okay, so this particular thing kada have the potential to cause harm to anyone. If I throw to someone, okay, so this particular kada will be called as hazard. On the other hand, the harm which is caused by this kada will be called as mishap. I hope it's clear. For second example, take it. I am a hazard, you know already that. Okay, so I have the potential to cause harm to anyone. Okay, so I am the hazard because I have the potential, and the harm which I am causing to others, whatever the injuries they will get, that will be called as mishap. Okay, I hope it's clear to you, but there are a lot of things that we need to understand now also. So guys, as I told you, these are two different states, hazard and mishap. So there is a state transition. It means hazard to mishap conversion is there. When these two are the states, then there will be state transition, no. When they are converting, a hazard is converting from a hazard to a mishap. So while the state transition, there should be two factors involved. It means two factors should be present, then only a hazard can be converted into a mishap. Okay, first of all, the first element is the unique set of the hazard components. That is your HE, IM and TT. It means already I explained you, hazardous element, initiating mechanism and target threat. Okay, I'll explain you that what is the meaning of unique set of them. And second one is the probability of mishap risk posed by this hazardous element. These two factors, unique set of hazard components as well as the probability of mishap risk posed by them. Now, as I told you initially, if a hazard want to occur, then there should be three elements present. Okay. Now, these three elements are hazardous element, initiating mechanism and target and threat. They should be present in a sufficient pattern. Okay, as well as second factor what I told you, the probability of mishap risk. It means how much is the probability is there to cause a mishap or to cause an actualized event. Okay, so based upon these two factors only, our hazard can transit into a mishap or an actualized event. Now guys, we'll give you one good example of that. We'll give you two examples. Just consider one molecule is there. Okay, one molecule is there. Consider molecule as a hazard. Molecule is a hazard. Now, as you know that within a molecule, there will be atoms inside that. Okay, as well as these atoms will be called as hazardous element. Not a hazardous element, hazard components. Okay, now as you know, three types of hazard components are there, and three must be present inside that. But it is not guaranteed that only one hazardous element will be there, one initiating mechanism will be there, one target and threat will be there. It may be more. You can think that 2 or 3 initiating mechanism will be there, 2 or 3 hazardous element will be there, and one target and threat will be there. So when these are available inside a molecule or inside a hazard, so hazard will not occur. Basically, these three elements must become in a proportion ratio. For example, they are randomly arranged inside a molecule, but when they want to convert from a hazard to a mishap, they should come in a specific ratio or specific pattern. For example, hazardous element, IM1, IM2, IM3 as well as target and threat. It means first of all hazardous element should come, after that initiating mechanism 1, initiating mechanism 2, initiating mechanism 3 and target and threat. This should be a proper pattern. Then only it can convert into a mishap risk. Second example, take it guys, we have 3 wheels, wheel number 1, wheel number 2 and wheel number 3. All the 3 wheels have holes. In the side they will be having one hole. Okay, and they 3 are moving at a at a same speed, but the hole is not coming in front of each other. Okay, so now these holes are denoting basically the different components of a hazardous element, basically hazard components. Okay, first hole will be at your hazardous element, second will be your IM, third will be your target and threat. So when they are moving, one time there is a probability that they will come in front of each other. For example, this particular wheel and this particular wheel will be having hazardous element, initiating mechanism and target threat in a direct line. So when these 3 are coming in a direct line, then only a hazard will convert into a mishap risk or a actualized event. So I hope it's clear to you. Now, when there is a transition stage, it means a hazard is converting into a mishap, actualized event. There are basically 2 factors or 2 things that occurs. First is your release of energy. Okay. Second one is point of no return. Now, what is the meaning of release of energy is guys? As you know that whenever a hazard occur, whenever a explosion occur, there is some sort of damage which people got as well as physical structures also got. So the energy which is being generated when a hazard is converting into a mishap, that particular energy is causing that damage. In every hazard you will see some damage. For example, if I throw that particular kada into the mobile, then mobile will got damaged. Why? Because of the energy which is generated from a hazard to a mishap transition. Okay. Second will be when a hazard is transferring into a mishap, when there is a transition stage, at that time there will be one point that will be called point of no return. It means you cannot reverse that. You cannot reverse a mishap to a hazard. Okay. So this is how they will work. Okay. Now guys, as I told you about 3 elements, the 3 elements of the hazard triangle, they are very important actually. We can understood that by an example of fire triangle. Fire triangle represents the 3 element of a fire which must be available in sufficient ratio to start a fire. Likewise, these 3 elements should be present in a specific arrangement to cause a hazard to exist. So basically this is the meaning of hazard in a system safety. When we discuss about system safety, so we need to go a bit of depth. Okay, so I hope it's clear to you now what is the meaning of hazard and how they actually occur. Hazard actuation and hazard mishap relationship theory. Okay, till now if you have any further doubts, you can put them in comment box with regards to hazard. I'll explain you. Okay, as well as I hope you will like this video. You have got a better understanding of hazard. So share this video with your friends, like this video as well as share and subscribe to this channel to your friends. So meet you in the next video. Till then, take care.